Hello, my name is Andrew Young. I'm an electrical engineering student here at ASU, emphasizing in power systems. I've had over a year of experience in power system design through an internship at Waterworks Engineers.
Hello, my name is Caleb Young, and I'm an electrical engineering student at ASU, and I'm currently interning at Waterworks Engineers as an engineering intern.
Hi, my name is Wesley Bergman. I am an ASU electrical engineer and work at Mercedes as a diagnostic technician for onboard electrical systems.
A common practice for the removal of solids from water by industries is evaporation ponds. Evaporation ponds are large man-made bodies of water that use sunlight to heat the water for evaporation. These ponds do not utilize the space they require efficiently because the ponds rely on increased size for greater evaporation rates. In nearly every instance of treatment plant construction, limited space and a tight budget is inevitable. This project will produce a small-scale prototype of an alternative to evaporation ponds that will condense the evaporation process into a small area using sophisticated motor controls and instrumentation, including variable speed drives. The evaporation system is encapsulated in a tank which internally incorporates biomimicry in the form of vertical channels produced by cylindrical rods to enhance evaporation efficiency by way of air-water interfacial contact. By utilizing PID motor control, the system will have the ability to vary the water and airflow to the system to produce the most efficient evaporation rate. The system will also have the ability to produce distilled water for reuse.
So what does success look like for a project? First of all, our goal is to achieve a process footprint equal to 5% of that of a typical evaporation pond to ensure maximum space savings for a client. Secondly, greater evaporation efficiency per unit area must be achieved if the evaporation distiller is to be considered commercially viable. Not only does the process need to be smaller, it also needs to be equivalent to an evaporation pond in industrial production capabilities. Lastly, the process ideally will be autonomous, only requiring minimal intervention from technicians and plant crews for maintenance and part replacement. What are some technical challenges we face? The first challenge Team 23 faces is finding an ideal way to step down the voltage from the solar panel. If this is not done properly, electrical components and power storage devices could be damaged. Another challenge facing the team is ensuring ideal power distribution to all the various active and passive process equipment and instruments. The next challenge involves the fine-tuning of the PID control system. The evaporator will utilize this control system to regulate process variables such as humidity and temperature to ensure maximum efficiency throughout the day. The final challenge is finding the ideal air-water evaporation interface needed to maintain as small of a process footprint as possible. This will require extensive testing and calculation to find the foremost capable rod geometry.
The project benefits are lower costs, optimized land use, independently powered by utilizing solar power, and the production of potable water for future use. These benefits to wastewater treatment will help lower costs for municipalities, which will in turn lower water costs for the local community.
The team consists of extensive industry experience in macro and micro power applications with access to ETAP, SKM, Picoscope, and CAD design programs to verify the designs and aiding in the proof of concept. All members of the team hold professional positions of which reinforce the skills learned at Fulton to aid in project completion. Together, the team has the hands-on experience and technical knowledge needed to reach the goals that have been established. The first semester will focus on the design schematics and simulation aspect of the project, including creating a working simulation backed by theoretical calculations. The deadlines of the project schedule aptly reflect this. Ultimately, the proposed design addresses the need for increased wastewater treatment by optimizing evaporation efficiency and decreasing the carbon footprint, objectives which will be achieved by precisely controlling the evaporation rate with power and control devices while concentrating the evaporation interface. The project is then further enhanced with autonomy and potability.